Welcome to the lesson 11 of the Advent of SysML v2. This is a training series consisting of short videos and exercises brought to you by Sensmetry in collaboration with Vince Molnár. My name is Kęstutis, and today you will learn what are the attributes, quantities and units in SysML v2 and how to specify their values. We can already model components in SysML, so let's investigate how to capture their attributes. Attributes in the SysML sense are data types. They should be used wherever you model the characteristics of something rather than its structure or relationships. Attributes differ from other elements in two main ways. First, instances are abstract, concepts like numbers with no identity. If two instances look the same, they are the same. Second, attribute usages are always referential. We just refer to values when describing something. There are several built-in attributes in the library. For example, scalar values contains all the usual number concepts. We can also create our own attribute definitions. Let's look at our model. On line 8, we declare attribute definition reindeer features to group all the interesting information about the reindeer. Notice on line 9, there is a comment. Members of attribute definitions are always referential, not variables. They never change and cannot be constant. On lines 10 and 11, we see two attributes, noseColor and eyeColor. Both are typed with color enum definition, but we'll come back to this later. We can say that attributes function similarly to immutable objects in programming languages, at least in this regard. Now, look at line 15, the reindeer part definition. Here we use reindeer features as the type of the attribute usage features. Attribute usages in other definitions are variable, unlike the members of attribute definitions. So they can also be constant, as we see here with the constant modifier. To change features, we would need to change the whole reindeer features instance, but we forbid this with the constant modifier. Now let's look at enumerations. They are a special kind of attributes. Look at line 27. We declare an enumeration called color using the enumDef keyword. Enumerations restrict values to those explicitly listed in the body of the enum definition. Lines 28 through 39 show each possible value declared after the enum keyword. So when we use color as a type, like in lines 10 and 11, the values are restricted to those enumerated options: orange, yellow, green, and so on. To summarize, attributes are data types used to model characteristics. They have no identity, and attribute usages are always referential. Enumerations are a special type of attribute where values are restricted to an explicit list. In systems engineering, most numerical attributes are physical quantities. Quantities are actually not standalone model elements. They are a set of standard attribute definitions in the quantities and units library. They are accompanied by attribute usages that further refine the role of each quantity. For example, there is a definition length value for lengths with usages like length, width, height that capture different roles. All standard quantities are in the ISQ package, International System of Quantities. The best way to use them is to subset or redefine one of the usages with our attribute. Let's see this in action. Line 12 shows antler length, which subsets ISQ length. Subsetting is the safer option. We are saying that antler length is a kind of length. Notice we are using the usage ISQ length, not the definition. This is the recommended approach. Now look at line 17. Here we have weight, which redefines ISQ mass. The definition says weight is the mass with no other kinds. Use this only if you want to prevent other kinds of the same quantity. So remember, subset is the safest when you want to say this is a kind of the quantity. Use redefinition only when you want to say this is the quantity and prevent other kinds. Although you can directly type with the quantity definition, it's better to use usages to refine the role. How do we specify the value of usages? This is done by feature values. We'll focus on the attribute usages, but the same principles apply to all usages. There are 4 kinds of feature values resulting from combination of 2 aspects. First aspect, initial versus bound values. An initial value denoted by := sign is applicable to variables only and constrains the value at the beginning of its owner's lifetime. In contrast, a bound value denoted by $= constrains the value for the entire lifetime. Second aspect, default versus non-default values. A feature value may also be a default value. A default value can be overridden when the usage is specified. If it's not a default, there is no way to change the value in specializations. Let's see examples in our model. Look at line 18. We have energy level with default followed by : = 100. This is default initial value. Initial because energy level may change. Default because we want to allow different reindeer to have different initial levels. Line 17 shows the default bound value, weight with default 110 kilograms. The sign equal can be omitted for defaults. Weight is constant for the lifetime, and default because we want to allow different reindeer to have different weights. Notice units in square brackets, kilograms. Units belong to the value, not the attribute type, and are specified after the number. A length can use any length unit, meters, centimeters, or even feet or inches. The conversion between units is automatic. Lines 5 and 6 import SI units from the SI package. Now let's see how we override default values in specializations. Line 21 shows that Rudolph is specializing reindeer. Line 22 overrides the features attribute with non-default bound value. Notice instantiation expression. New reindeer features, color red, color brown, 60 centimeters. To specify a complex value like an instance of reindeer features, we use an instantiation expression. The new keyword, then the type, then the parameters in parentheses. Values are assigned by position. Rudolph's nose is red, eyes are brown, and antlers are 60 centimeters long. Next, line 23 overrides the weight with non-default bound value of 100 kilograms. And on line 24, it overrides the energy level with non-default initial value of 200. These overrides would give an error if we had not used default feature values in reindeer definition. To summarize, feature values specify values of usages. They can be initial or bound, and default or non-default. Units belong to values, not usages, and are specified in square brackets. Instantiation expressions use the new keyword to construct complex values. So there you go. You are now familiar with SysML v2 attributes, enumerations, quantities and units, and you know how to specify them. Today's challenge is to model SantaSlay with physical attributes using what you learned in this lesson. See the blog post for full task details. Share your experiences and feel free to ask questions about this or any past lesson in the community forum. Links and information how to get access to Syside cloud platform is available in video description. Subscribe to our YouTube channel and click on the bell icon to get notified about future lessons. Tomorrow, we'll dive deeper into more SysML v2 concepts. Take care and happy modeling!